Good morning. The next topic is DMA, Direct Memory Access. Myself, I am Suresh Babu, working as an Associate Professor in the Department of ECE, Hindustan College of Engineering and Technology. In the introduction about Direct Memory Access, for those applications which require huge amount of data to transfer from memory to the processor, we have to use this DMA controller. This DMA controller temporarily borrows the address and data bus from the processor and it transfers the data directly from the disk to the series of memory locations. Some of the DMA devices even can do transfer memory to memory devices. The normal operation of the memory transfer is through the processor. We cannot directly transfer the memory from memory to memory or other external devices. All the memory operations are being carried out with the help of the processor. Here in the case of direct memory access, we are borrowing the content of the buses, that is the data bus, address bus and the control bus will be borrowed from the microprocessor through some request and directly transfers the data from memory to other devices without the support of the processor. This is a block diagram of DMA controller. Here this is a CPU. CPU may be a processor like 8085 or 8086 processor. These are all the available buses. The available buses are control bus, address bus and data bus. This is a DMA controller. This is a DMA controller. These are the devices which is being connected with the DMA controller. Here the condition is to transfer the data from device A to device B. The normal process is device A have to transfer the data with the permission of the processor or through the processor the data is to be transferred. That is a normal process. Here we have a DMA controller. This is an extra block. Now we are going to transfer the data without the permission. That is not without the permission. That is with the control of these buses. We are going to transfer the data from device A to device B. And here a block diagram of DMA transfer data scheme is available. This is a detailed diagrammatical illustration. Here this is a microprocessor. This is a microprocessor blocks. In the microprocessor, the lines are available. Address lines and data lines are available along with the ALE signal. ALE is address latch enable. The purpose of ALE is to separate the address and data. Here along with this processor, we have latches. That is to temporarily store the values. We need some latches. And here now this address is transferred through these latches and the data is being separated from the address data bar line. Now here comes the data bus and here is the address bus. This is the memory. This is the memory. And now the control is available. The control bus is there. The controls are IOR, IOW, memory read and memory write. These are all the controls. We can do different operations. We can do 4 different operations. One, we can do IO read operation, IO write operation, memory read operation and memory write operations can be performed. Here initially this is a DMA controller. This is a DMA controller which is available below. And these are the peripheral devices. You can connect a number of peripheral devices along with these block. Now the initially the peripheral device will send a request DREQ, and this DMA controller what it does means this DMA controller will send a request to this microprocessor. This is a hold request, right? First initially this DMA controller will send the hold request. Once the hold request is received by the processor, it sends the acknowledgement request, and the meaning of this request is to transfer the buses. Once this acknowledgement is received, then automatically this microprocessor will be in sleep mode, the transfer, it will automatically transfer the bus control to this DMA controller. Now after receiving the control of receiving the buses, this DMA will directly transfers the data from memory to memory, or to these external devices. Okay, thank you.